Today, we're diving into something that sounds like it's straight out of science fiction. We're looking at a paper that suggests a totally new way to move through space, one that seems to break one of the most basic rules of physics we all learn. Let's get into it. So to really get how wild this new idea is, we need to start with the basics. Think about a rocket. How does it actually get off the ground and soar into space? It's pretty simple, right? It blasts hot gas out of the back at incredible speed. And that action of pushing the gas down pushes the rocket up. It's a perfect example of Newton's third law. For every action, there's an equal and opposite reaction. And it's the exact same principle for us right here on Earth. I mean, how do we even walk across a room? Our feet push backward on the floor, and in return, the floor pushes us forward. Every single way we move, whether it's a car, a boat, or a plane, it all boils down to this one rule. You have to push against something to move. But what if you didn't? And that brings us to the core claim from the research we're examining today. The authors state, and I'm quoting here, quote, "In order to move, it is not necessary to use this law." I mean, wow, that's a huge statement that challenges centuries of physics. So how on earth could that possibly work?
Well, the paper proposes a completely new kind of propulsion. It's not based on throwing mass out the back, but on manipulating the very atoms inside an object itself. The key to this whole thing is a field of physics called nuclear magnetic resonance, or NMR for short. And you've probably heard of this before, even if you don't realize it. It's the science that makes MRI machines in hospitals work. But here, it's being proposed for something totally different.
To really understand how NMR could make something move, we have to shrink ourselves down, way, way down, to the atomic level, and see what's going on inside the nucleus. Okay, that definition sounds super complicated, I know. But the idea behind it is actually pretty straightforward. Basically, certain atomic nuclei behave like tiny spinning magnets. And when you put them inside a powerful magnetic field, and then zap them with a radio wave, they react in a very specific, predictable way. Let's see what that looks like. So on the left, you've got a nucleus just on its own. Its little magnetic pole is pointing in some random direction. But look what happens on the right. When you apply a strong external magnetic field, boom, the nucleus snaps into alignment with it. Now, all those little atomic magnets are pointing the same way. But here's the cool part. The nucleus doesn't just sit there perfectly still. It starts to wobble around the axis of that magnetic field. And the absolute best way to picture this is to think of a spinning top, right before it's about to fall over. That wobbling motion is called precession. And this is a really crucial point. That wobble, that precession, it isn't just a neat little visual. It's a real physical property. It means that every single one of those aligned nuclei now has its own tiny bit of angular momentum. And this is where the magic really starts. So we've got this material that's full of atoms, and they're all aligned and wobbling in perfect sync. How do you turn that into actual physical movement of the whole object? Well, the answer is a quick blast of energy, specifically a radiofrequency pulse, or an RF pulse. As you can see here, when you hit those aligned atoms with a very precisely timed RF pulse, it knocks them off their axis. It changes their individual wobble. This next part is everything, so let's break it down into 4 steps. First, you align the nuclei in a magnetic field. Got it? Second, you zap them with that RF pulse, which changes the angular momentum of each individual nucleus. Third, and this is the absolute key, the universe demands balance. The law of conservation of angular momentum says the total spin of a closed system has to stay the same. So if you've just changed the spin on the inside, the system has to do something to compensate. And that brings us to step 4. In certain materials with a specific crystal structure, the only way for the system to rebalance the books is for the entire object to move. Look, I know this sounds like pure science fiction, but the researchers behind this paper claim they've actually demonstrated it in a lab. So let's take a look at the experiment they ran. The setup itself was pretty straightforward. They took a disc made of bismuth, and that's a very important choice because of its unique crystal structure. They put that disc between some powerful magnets to get all the nuclei aligned, applied a strong electrostatic charge, and then they hit it with that targeted RF pulse. And here you can see the actual schematic from the paper. You've got the north and south magnets, and that gray bismuth disc is sitting right there in the middle, just waiting to get pulsed with those radio waves. So what do you think happened? The disc began to rotate, with no rockets, no propellers, no pushing of any kind. Just by manipulating the atoms inside of it, the object moved. According to the paper, when that RF pulse hit a certain power level, the disk would just make a partial turn.
Now, if this result can be copied and scaled up, the implications are, well, they're almost impossible to overstate. This isn't just a new kind of engine, it's a whole new physics for how to get around.
So what does this all mean? Well, it suggests you could move an object using only energy. You wouldn't need to carry massive amounts of rocket fuel. For space travel, this would be a complete and total game changer. The paper even suggests that a craft could use the existing magnetic fields of the Earth or the Sun to maneuver, just sipping energy to adjust the spin of its atoms. Now, obviously, this is very, very early research, and a lot more experiments are needed to prove it out. But it really pushes you to ask a pretty profound question. We have always looked outward, pushing against the world to move. What if the secret to exploring the universe wasn't out there at all, but was locked deep inside the atom the whole time? Could the simple wobble of a nucleus really be our ticket to the stars?